Welcome back to the Ephemeris podcast. I'm your host, Aphelion, and I apologize for not having dropped an episode on Sunday. I did create a little post explaining why, but here we are, middle of the week, doing a podcast episode. And the maximum number of episodes we're going to have beyond this point for the season are going to be three. They're just a handful of mid 20th century astronomers to look at, and then we're into the next phase, as I've discussed briefly in some of the other episodes previously. But that is for later. Today, we're going to look at one astronomer in particular briefly, and his name is George Herbig, and he's obviously associated with the Herbig Haro object, but he's also known for Herbig Ae and B stars, and is considered the father of early star formation given his works. So, with that being said, let's get into a very brief biography section of the episode. Not much is known about George Herbig's life. He was born in Wheeling, West Virginia in 1920, and he was an only child. And unfortunately, his father died early in his life, and Herbig ended up moving to LA and became fascinated with telescopes. So from there, he joined the LA Astronomical Society and met many great astronomers while also getting the chance to go to the Mount Wilson Observatory. And George Herbig did his studies at UCLA and completed his PhD in 1948 with a dissertation titled A Study of Variable Stars in Nebulosity, which investigated T Tauri variables, which is one of those protostars or protostar phase kind of celestial objects. And as a refresher, they're in the pre-main sequence phase, which they're following the Hayashi track, which is a luminosity temperature relationship obeyed by infant stars of less than 3 solar masses. So those are what T Tauri variables are, and that is what Herbig was studying in his PhD dissertation. And at the time, these objects were curious. It was theorized that the huge brightness of these stars was just because there's a lot of gas and interstellar medium in the mix, and they're passing through these stars, which is increasing their luminosity. And this was a theory that was supported by Herbig's mentor, but what Herbig did was converge towards the idea that T Tauri variables are actually young stars releasing energy due to gravitational pressure. So that is one interesting idea. And for the next few decades, Herbig will go on to investigate many peculiar deep sky objects similar to T Tauri variables that will lead to some huge discoveries, and a lot of them are going to be more pre-main sequence focused, but still going to be very important because, that early phase of a star is important to understand stellar evolution. In 1951, Herbig discusses two nebulosities near NGC 1999, which is also known as the cosmic keyhole. The reason why it's called the cosmic keyhole is because the middle of what it is a mostly bright nebula is truly empty. So imagine just, a nebula with just an empty center. That's what NGC 1999 is. But that's not what Herbig was looking at in his work. He actually discovers a Herbig Haro object near the cosmic keyhole, which he describes as, quote, a slightly diffuse star with a very short curved nebulous tail. And so that came about in 1951. In 1968, Herbig looks into R Monocerotis, a binary star in the Monoceros constellation. Hopefully I'm saying these names correctly. And when he's investigating this matter, he comes across a weird dilemma. It's not completely clear what R Monocerotis is. He says at first sight it seems to be a nebulous star, but when you look at it in a higher resolution, it's actually a triangular nebula. But then he also considers that there may be Herbig Haro objects, just like what was going on with the cosmic keyhole in 1951. What we now know about R Monocerotis is that it is a Herbig Ae/Be object, and in 1962 and 1960, Herbig will publish work that puts together his sustained investigation into T Tauri stars and Herbig Ae/Be stars, respectively. So all of this work that he's been putting into looking into these really specific celestial objects for certain kinds of stars, it's really gonna sum up in these two works. I don't have full PDFs to these works, so unfortunately we won't have anything to deep dive into, but yeah, we're just kind of going to have to suffice with or sort of just be happy with a surface level description of these two works. We should talk about what Herbig Ae/Be stars are, though. They're pre-main sequence stars, just like some of the other objects we've been discussing, like T Tauri variables. Just like them, Herbig Ae/Be stars are pre-main sequence stars, but the main thing to know about them is their spectral class and how that differentiates them from T Tauri variable stars. They have spectral classes A and B, as would be expected from the name, and they have hydrogen and calcium lines, which is pretty expected for those spectral class types, and that's kind of what differentiates them from T Tauri stars. There are things that they do have in similar, though, which are Balmer emission lines. And in terms of stellar evolution, Herbig Ae/Be stars will undergo large variability, usually because there's gonna be a lot of matter clumping in the circumstellar disk of these objects. So luminosity is gonna change based on all of this matter clumping that's going on. So yeah, that is pretty much the best I can do to sum up the work of George Herbig with the little information that I do have about what he did. I think it's definitely interesting, even just the general gist of what his work is, let alone what might be or what might become obvious in the specifics of the work. So yeah, I wanted to cover him, and the rest of Herbig's career beyond pre-main sequence stars are pretty much just going to be some miscellaneous objects, but they're still peculiar, similar to the cosmic keyhole, which we've only recently found out has that really empty space in the center and stuff like that. George Herbig does study FU Orionis stars, which we've talked about previously on this podcast. If you want to go check that podcast episode out, you're welcome to. He theorized that these objects, they're kind of the FUR event in general, represents rapidly rotating young stars near the point of breakup. So that's kind of another little cherry on top to some of the really important work that Herbig did to figure out sort of the pre-main sequence era of the stellar life cycle. So yeah, that's all I've got for you today. If you guys listen or enjoyed listening to this podcast episode, I would sincerely appreciate a follow or subscribe, depending on where you are listening. Feel free to share this podcast and the episode itself. I know I don't mention that very often, but obviously sharing would help increase exposure to this kind of content. And yeah, until the next podcast episode, I will see you all later. Peace.